this with respect to p by chain rule, and then we have this kind of expression delta y naught 2p minus 1 upon 2 factorial delta 2 y naught, and like this. Here p equals to this one, and dp over dx that is required, and when we apply the chain rule, so dp upon dx is 1 upon h. So, and then we have substituted p equals to 0 because we want the derivative at x naught. So here we replace the x by x naught, and we get the derivative at x naught. In general, we can put x equals to x and we will get the derivative. So like after this, we are having applying this chain rule, we have this one dy over this, and then dy by dx at x naught is this. So this is the like our Newton forward derivative formula, and here we are calculating derivative at the point p equals to 0. So when like some problem is given and it's equally spaced data, then when someone asks you to find the derivative at initial point, even though he has not stated whether you have to use which formula, so if it is he is asking you from at the initial point, so you have to use this formula. And then similarly we have calculated the second derivative also, and the derivative for formula for second derivative is this one, and at initial point is given by this one. Then we have developed formula for Newton backward derivative by using Newton backward interpolation formula. So this one is Newton backward interpolation formula, y equals to yn plus p nabla yn plus p into p plus 1 upon 2 factorial nabla 2 yn, like this. And then we have calculated del y over del p, that is this one. But here p is this one, so dp over dx is this one. And then you apply the chain rule to calculate dy by dx. So after application of chain rule, you have this as an expression. And here you can put like a p can be anything, but in general we are when we use the backward interpolation formula, we calculate the derivative at the last point. So if here if I substitute p equals to 0, so if p equals to 0 means this h is multiplied to 0 and then x equals to xn, or you can say when x equals to xn, p should be 0. So if you want the derivative at x equals to xn, this p will be 0. And when you substitute p equals to 0 in 5, you will get this as a formula to calculate the derivative at the last point. And then similarly we can use the chain rule again to calculate the second derivative, and the second order derivative is calculated by this formula, in particular at the last point when p equals to 0 or x equals to xn. We have this one as the formula. Then sometimes like the derivative is required in the middle of the table. So for the middle of the table, we will use our Stirling formula. So if you remember, this Stirling interpolation formula is the average of Gauss forward interpolation formula and Gauss backward interpolation formula. So if you take the average of Gauss forward and Gauss backward interpolation formula, you will get your Stirling interpolation formula, and on the basis of Stirling interpolation formula, we can calculate the derivative at the middle point of the table. So like if someone asks you to find the derivative at the middle point, then you have to apply this formula, Stirling derivative formula. So here we know that when we have taken the average of Gauss forward and Gauss backward interpolation formula, we get this kind of expression as a Stirling interpolation formula. And in this case, p again x minus x naught upon h. So we'll again calculate dy over dp. In dy over dp, you can see that if we are differentiating this with respect to p, obviously this part is 0, and here p is only of 1 degree, so this will remaining, and here 2p is upon 2 factorial, like this. And similarly you can write derivatives, but we have to calculate derivative of y with respect to x, and x and p is a function of x minus x naught upon x. So we apply the chain rule, and the chain rule is this one: dy by dx equals to dy over dp into dp over dx. Dp over dx is 1 by h because p is this one, and dy over dp we have already calculated here. So we substitute this value and these two values, and we will have this one as the formula to calculate derivative at the middle point of the table. So here, like when you substitute x equals to x naught, here actually p is equals to 0 because p is x minus x naught. So here like we are writing like x equals to x naught, and it's look like that it is initial point. But we know that when we are dealing with the Stirling formula, then when we are dealing with the Stirling formula, we select this x naught at the middle of the table. So when we select this x naught at the middle of the table, so x naught is now is the middle point, because when we are dealing with the Stirling or central difference formula, we select this x naught as the middle point. So we put p equals to 0, and this is the formula for calculating derivative at the middle point of the tables. Similarly, like if you differentiate it one more time with respect to x and again apply chain rule and again substitute p equals to 0, you will get this as a formula for your second derivative. So, and the problems we have already discussed, like this one is for this table is given, and first you have to check whether it is equally spaced or not. So it is equally spaced. For unequally spaced, I already told you to just find the polynomial using either your Lagrange interpolation formula or Newton divided interpolation formula, and then differentiate that polynomial and later put x equals to something, whatever wherever the derivative value is required. Or you can take the method that we have constructed the formula for this unequally spaced data and discussed in earlier classes. You can apply those formula also. Now here, this is our given data, and here we have to calculate the derivative, first derivative and second derivative at the initial point. Sorry, x equals to 1.1 and at the last point 1.6. So you first create your difference table. This is your difference table, it is extended in the second page also, and you know how to construct. Did you write x values, you write y values, and this minus this will give you this minus this will give you this. Like that you construct your difference table. Now the formula for derivative at the initial point x equals to x naught is this one. So dy by dx at x naught is 1 upon s delta y naught minus 1 upon 2 delta 2 y naught plus 1 by 3, like this. So now you can observe one thing. The earlier when we have to calculate the derivative at the new point x equals to 1.1, because you can see now here x naught is, if we see the x naught is first point is 1.0, but here they are taking x naught as 1.1. So they have taken the formula same as which is for the initial point x naught. This is the Newton forward derivative formula for the initial point, and they have shifted their initial point to this point. So if they are taking this as an initial point, so they have not there is no requirement to apply like a p equal to plus 1 in the formula, like when we developed the Newton derivative formula. So like when p equals to, when it here it is required, then p equals to 0 you put and you will get this kind of formula. But when at this point is required, you put p equals to 1 and then you will get the new formula for this point. But now what they are doing, like this is they are taking as an x naught, and assuming this as a y naught, and then this is as a delta y naught, this is as a delta 2 y naught, and like this they are taking the values. So if they are taking the values like this, so we can apply like this formula as it is. So that's why I told you to remember this form of the formula, and this can be applicable. So like if this is the x naught, so table interpretation is changed. Like this is x naught, this is y naught, this is delta y naught, this is delta 2 y naught, delta 3 y naught, delta 4 y naught, and delta 5 y naught. So you have substituted all these values because delta 6 y naught is not exist, or we take as a 0, and then they have evaluated this. So this is also. Or you can do one thing, like you put p equals to 1. Put p equals to 1 in the Newton forward interpolation formula, and when you put p equals to 1 in the Newton forward interpolation formula like this, in this formula if you substitute p equals to 1, you will get the derivative formula at dy by dx at x1, and now your x1 is like 1.1. So then this is this form is not there, some other form is there. Next is then it is at the last point, so we apply Newton backward interpolation formula. So there is no need to construct the table again. We know that the values will be the same, just interpretation is changed because xn is 1.6. So this is yxn, this is nabla yxn, this is nabla 2 yxn, this is nabla 3 yxn, nabla 4 yxn, nabla 5 yxn, nabla 6 yxn. And then we apply our Newton backward interpolation formula at the last point. This one is our Newton backward interpolation at the last point. So this is like this is same as our forward, just forward differences are replaced by backward differences, and all alternatively coming minus are actually all plus terms are there. And then you substitute the value of delta yn, delta 2 yn, delta 3 yn from here. Yn, delta 1 yn, sorry, nabla 1 yn, nabla 2 yn, nabla 3 yn. So you substitute all these values, you will get this is the derivative at the last point. Similarly, you can calculate at the second derivative also. Okay, so here in this formula, like we have to find the derivative, and like t and x is given, and they are asking what is the velocity and acceleration. So first and second derivative required. So here, like you can see, this is the midpoint. So now you think this as your x naught. So this is your x naught, and this is your y naught. Okay, they have actually changed the variable like x by t and y by x. So you have to interpret like that. This is like actually t, earlier we take this as a x and this as a y, but now this is t and the y is played by x. So this is like you can say t naught, and this is x naught, this is delta of x naught, no sorry, this below one is delta of x naught, and this is delta 2 of x naught, delta 3 of x naught. If this is t naught and this is t minus 1, so it means it is x of minus 1. If it is t minus 2, it is x of minus 2, and t minus 3, x of minus 3. So this is like x naught, delta x minus 1, delta 2 x minus 2. Because you know that in when we are having this central difference formula, like Stirling formula, these values are important to us because this is x naught, this is t naught, and this is corresponding x naught, this is delta of x naught, this is delta minus 1 of x naught, like this. So these values we required, and this is the formula for the derivative at this x naught, at the center or middle point of the table by using Stirling formula. This is like this: delta of x naught, this is delta of x, sorry, this is delta of x naught, and then delta of x minus 1. This one is delta of x minus 1, then delta of x minus 2. So like this, we substitute all the values and we will get this as the first derivative at middle point of the table. Similarly, the second derivative also. So here again, like we have something, data is given and this data is equally spaced, and we have to calculate derivative at the this point. This is middle point. So you say again, this one is your x naught, and so this is your x naught, this is your y naught. So this is x minus 1, x minus 2, x minus 3, and similarly this is y minus 3. So then we have this our Stirling formula for the first derivative. So Stirling formula is this: 1 upon s delta y naught plus delta y minus 1. So this is delta y naught and delta y minus 1. Then delta 3y minus 1 is required. So this is delta 3y minus 1 and delta 3y minus 2. So this is delta 3y minus 2. And then you substitute these two values, and then require delta 5 minus 2. So delta 5 minus 2 is this one, and delta 5 minus 3. So this is delta 5 minus 3. So these values are required in the derivative formula. So it means this middle, these columns we have to skip, and then we substitute the values, and then you get the derivative at the middle point. So like this, you have to find the derivative at the middle point of the table, and there is nothing much to discuss more for today. So, and I will give you a assignment like having problem, that kind of problem may also come in the exam, and you have to submit the written assignment after the exam. And the syllabus of the midterm is like from the first lecture till today, whatever teach to you. And if you have any question, you can ask. Otherwise, I am taking the attendance for today. 1,
Present, sir.
2,
Present, sir.
3, 4, 5,
5 present, sir.
6,